In this video, I'm going to discuss the distinct prime factors of product of array problem which occurred in today's weekly 326 lead code challenge. If you have any doubt regarding any of the questions or this code, you can ping me up on Instagram, or even you can join my Discord server. I will pin both the links in the comment section. Okay, I will pin them. So it states that you're given an input of an array. Okay, this is an array. This is also an array, and first of all you have to find the product of the all elements of the array, and then you have to find the number of distinct prime factors of the product of the array. Okay, so now the basic thing that it states is, first you have to do 2 into 4 into 3 into 7. Sorry, it got blurred. Yeah, so 2 into 4 into 3 into 7 into 10 into 6, and when the number comes, then you have to check number of prime numbers which divided. Okay, number of prime numbers which divided, and then again 2 into 4 into 8 into 16, and the answer which comes, you have to check number of prime numbers which divide that answer. But there is one thing given in the question, that is length of the whole array is of the range 10 to the can be of the range 10 to the 10 to the power 4, and nums each element can be of 1000, that is 10 cubed. Okay, so if you check this out, so the what could be the maximum product of this? It could be 10 cubed into 10 cubed into 10 cubed into dot dot dot. No, that is 10 to the power 4 number of times. Okay, 10 to the power 4 number of times, which is obviously outside the range of long, double, anything you take, which will, if you take double, it will execute, but it will give you a TLE. Okay, so the basic idea that we have to find the product and then find the number of prime numbers, that is going to be a very bad idea. Okay, so what we have to do first is we have to make, I'm not going to give you the pseudocode, I'm just giving you the logic. So you have to first you have to check the number of prime numbers from the range 1 to 1000. Okay, so if you can check it by a code, it's okay, but I can tell you that it will be 168. Okay, there are 168 prime numbers between 1 and 1000. So initialize an array of size 168. Once you're done with this, then now there is one thing, that let's say int k is equals to 2, and then uh, k is equals to 2 and j is equals to 0, while j is less than 168. That is all the elements of this array. Okay, while j is less than, so first of all write ARR of j is equals to k, then k plus plus, while not prime k, k plus plus, and then j plus plus. Okay, so this will do nothing but fill the array ARR with all the prime numbers, that is 2, 3, 5, 7, and dot dot dot. Okay, it goes on filling it, and then you have to do one thing, that is you have to run a loop throughout the whole array, that is for I is equals to 0 to I less than nums dot length. Okay, I plus plus, and inside this you have to check. Okay, you have to check, that is for j is equals to 0, j less than 168, j plus plus. So if this thing, this ARR of j divide, okay, if num mod ARR of j is equals to 0, then BRR of j plus plus. So what is BRR? BRR is going to be also another array of length 168, and there is going to be a blank array. Okay, that is 0 0 0 dot dot dot. Okay, so this states that how many times this the element at this position divides the number. Okay, so plus plus, if num mod AR of j is equals to 0, BR of j plus plus, and then j plus plus, because you have to, okay, no, j plus plus occurs over here, so This is a basic code. Okay, this thing. And once done with this, the final thing would be I is equals to 0, I less than 168, I plus plus, if BRR of BRR of I greater than 0, count plus plus. And once done with this, if you just return count. So let me, like, this is not the pseudo code, obviously you have to code it by yourself. So let me tell you what I am doing. First of all, I am using this formula, this thing, so this code to get the array ARR, which are the prime numbers 2 3 5 7 uh, 11 13, okay, dot dot dot. And then we are going to run a loop throughout the whole array, and for each element we are going to check how many numbers divide them. Okay, so let's say for 2, so let's give it a dry run. So let's see 2 4 3 7. Okay, let's write it down. 2 4 3 7 10 6. Okay, now what is ARR? ARR is 2 2 3 5 7 11 13 dot dot dot. Okay, because we don't need them, because 13 is the maximum element over here. And what is BRR? BRR is 0 0 0 0 0 0 0 0 dot dot dot. Okay, so for 2 we have to check with the first element. 2 divides 2, yeah, it divides it. 3 divides 2. Okay, one more condition. In this case, if ARR of J exceeds number, that's nums of I, then we break it. Okay, remember one thing. So 2 and 3, so 3 is greater than 2, so we break it. So 2 divides 2, so this thing becomes 1. Okay, now 4 divides 2 divides 4, yeah, it divides 4. Okay, 3 divides 4, no. 5 divides 4, we don't even need to check it because 5 is greater than 4. So for 3, 2 divides 3, no. 3 divides 3, yes, it divides. 5 divides 3, we don't have to check because 5 is greater than 3. 7, 2 divides 7, no. 3 divides 7, no. 5 divides 7, no. 7 divides 7, yes. 7 divides 7, yes. Then 11, 7, 11 is greater than 7, so we don't need to check it. Then 10, 2 divides 10, yes, it divides. 3 divides 10, no. 5 divides 10, yes, it divides. 7 divides 10, no. 11 is greater than 10, so we don't have to check. For 6, 2 divides 6, yes, it divides. 3 divides 6, yes, it divides. 5 divides 6, no. 7 divides 6, we don't have to check because 7 is greater than 6. So now we have to find out the number of elements in BRR which are greater than 0. That is, this is greater than 0, this is greater than 0, this is greater than 0, this is greater than 0. So there are 4. So the answer was, so the output was 4. Okay, this is the verified thing of the whole thing. This was a nice code. If you understand the logic behind this, then the code is very simple. You can code it. Thank you.